Hey everyone, I hope. Okay, I think we are live. Great. So today we're going to talk about approaches to move from local development and to staging with Hasura. So typically, you will start off by using Docker on your local machine, on a dev machine, and you will proceed towards creating a staging environment and then finally to production, right? So there are various things to consider while doing this. So today we're going to go over this whole workflow of doing something on local and changing a few things, applying migrations and metadata, how to make use of environment variables, and also to like apply the same configuration onto a cloud project, right? Cool. So I'm just quickly looking at um, the comments. Great. Cool. So what we're going to do is we're going to set up the local instance of Hasura. So I'm going to go to the docs for the Docker Compose setup. So the typical way to run your Docker container is through Docker Compose, where you have both Hasura as well as Postgres combined. So if I can just use the Docker Compose setup. Um, right. So this is Docker. I'm just gonna search for Docker Compose. Right. So I'll just duplicate this. I hope the terminal is visible. Great. So if I cap this Docker Compose, here we see that we have the latest version of Hasura, and Postgres is version 12, right? So now what I'm going to do is I'm just going to do Docker Compose up -b. This is also assuming that you already have Docker in your machine and you have Docker Compose set up to be running. So what this will do is this will obviously pull Postgres, the Docker image for Postgres version 12, and the latest version of Hasura uh, from the Docker Hub, right? Once you have this running, in fact, in another tab, we can actually look at the different environment variables that are being configured by default. So we have the database URL, which is configured to the local instance of Postgres. And we have the console being enabled by default. This is obviously useful in local development. Then we have a few other commented environment variables. We'll come back to them once we have a setup ready. So right. So once we have a local environment ready, the next step is to explore the console. But there are two ways to do that. You have the Hasura console being served by the server, and you also have the Hasura console, which can be served through the CLI, right? So we'll see the different approaches. Now my Docker Compose is ready. So I have my containers running. So this is on my Mac. The setup will be very similar on Linux for both running GraphQL engine and Postgres. Right? Cool. So if you look at this, this is running on port 8080. So I can actually go to my browser and open localhost 8080. And yeah, so here, this is the console that you see typically served by the server on localhost 8080. So when you're starting off a local development workflow, the easiest thing is the easiest thing that you will probably do is just create tables and then start exploring the GraphQL APIs directly on the console, right? Now, the other approach is if you want to actually have a migration workflow from the beginning, you will actually have to use the CLI so that you start tracking your activity as the database schema state changes through the migrations, and you have a version control system of migration files being generated for each schema change that we make. So we're going to make use of Hasura CLI for that um, to serve the console. So if I go back to Hasura CLI, there has to be a setup, right? So you can install Hasura CLI first. I already have CLI installed on my machine, so I'm just going to do Hasura version to confirm that. Yes, so I have the latest version of Hasura CLI ready. Just looking at the comments here, they have some solutions about problems here. Cool. Great. So now that I have Hasura CLI ready, I'll init an empty directory, empty project with the CLI. So if I look at this setup, it has created a Hasura folder, which will have a few files and directories. The config.yaml typically has the default configuration for the endpoint and the version of the metadata and the directories for actions and metadata, right? So, and if you look at the metadata folder, we have actions, the love list, the cron triggers, tables, the remote schemas and relationships and whatnot, right? So all of these are like individually separated out as YAML files, except for the actions, which also has GraphQL types. So you will also have actions.graphql in it, right? So obviously that's now it's going to be empty, but here you will have the GraphQL types being generated. Cool. So I can actually do a tree to show you metadata is there. The migrations folder will be initially empty. You also have a seeds folder, which can have like an initial database seed for sample data to start testing it out. Great. Let me just uh, so once the CLI is set up, what I'm going to do is I'm going to actually open the Hasura console through this. I'm going to do Hasura console. This will open up on my browser. I'll open it on Chrome. I have my default browser set up to Safari. Right. So we have the Hasura console now being served at localhost 9695. If you look at the terminal, it says console running at 9695. So everything is pretty good. But if you notice the difference between this console and this console, the difference is actually that in the data tab, if you go, there's a migrations tab, right? So what this will let you do is it will let you start tracking Postgres schema changes as migration files. But if you look at the server console, obviously you won't have this because the server doesn't have a way to pipe the files to your directory. So the Hasura CLI does the job of creating the migration files as you keep changes to the database. Great. So I'm going to close this. Ideally, when you want a metadata or a migration workflow from the beginning, it's easier to just start off from the Hasura CLI and not use the console served by the GraphQL engine server, right? So we can close this. We can start using the Hasura CLI setup. Now I'm going to go to data to create a table. Let's say we build a simple commerce store, a schema for a commerce store which has some users and products to just showcase the different workflows, right? Great. So I'm going to create a table called products with columns ID, auto incrementing integer. Typically, I would recommend UUIDs for IDs. I have a name for a product. Let's see, the product also has an image, um, more like an image path. And I'm going to click on created at and updated at as default timestamp columns. You also use the primary key ID. And the interesting thing that happens with add table here is that the table gets created in Postgres, but also if you look at your migration folder, you will see that there are files being created. So if I do a tree here, in your migrations directory, you see that there are a couple of files being generated. Um, the first is the up.sql, and there is a down.sql equivalent to that. So I go to migrations, and I can just cat file. So what this has done is basically just created an SQL migration for the table that we have created. So console does this automatically for you. As you use the UI to manage your database schema, the console will generate these SQL statements depending on the selection that you've done for the table, and then it will create the necessary migration files. Right. The file creation happens at the CLI layer. The SQL generation happens at the console layer, right? Cool. So now this folder, right? I can actually just do a git init. I can just start committing these files. If I do a git status, so now all of these metadata and migration files can be version controlled. So this folder structure can be part of any of the repos that you maintain as part of your application. So let's just say I added product table to schema. So now I have the commit history, which is tracking all of this migrations being created, so that in the future, if I want to probably roll back to a different version, I also know when was this change made, right? Um, right. Cool. So I have the product table created. Now let's also create the users table. Again, an ID. Say name as a text. Stick to very basic column structures, and I have a primary key ID. Got it. I think so. There's a question from Spencer Polly. The question is, my metadata isn't broken up into multiple different files. It's just a metadata.yaml. So it's true. So the thing is that with Hasura 1.3, or sorry, in fact, once Hasura 1.2, the metadata handling has changed. We have a new version of metadata, which breaks up each individual pieces of the schema into separate metadata files. For example, tracking tables is a separate file, and actions and remote schemas and events, all of them have their individual metadata workflow, right? Prior to this, we had a single metadata.yaml file, which will just output the entire metadata required for the whole app that Hasura maintains, right? From V 1.2.0, I think. We have a newer version of metadata, and you should also be able to use the CLI for migrating this metadata version from your V1 to V2. So if I actually go back to this and show you that in this config, if you see the version of the config is 2, which is the metadata version is 2. This actions being here, these are all new and is not part of your version 1 of the metadata, right? So you can technically just migrate using the CLI, which will automatically take care of the file transformations that are required. Awesome. Great. So now coming back to the table. So I've also created a user table. So if I do a git status, you can see that metadata has changed, and there's a new folder for public users table being created. So this just gives you an idea that as you make schema changes, you will start seeing files being generated automatically for you, and you can just version control it, right? Cool. So now let me also like create some relationships and a few other metadata stuff. So let's say product has images, multiple images. So I'll say product images. You can do integer, do product ID, which will have an integer, and that could be like an image path. So this could be like the product table could have a featured image, and this could probably be other smaller images. Yeah, the idea that I'm trying to go for is to create a relationship between two columns. So we have product table as a base, and we have like a product image table in addition, right? So what I'm going to do is I'm going to create a foreign key constraint for this column product ID, which will be mapping to the product's ID table, product table's ID column, sorry. So this will go to products from product ID to the ID. I'm just going to save this. So once we have this foreign key constraint, um, we can go back to relationships tab, and we can see that an object relationship has been suggested. I can add this. And if I go to products table, I can also add like a array relationship, because from products to images will be one to many mapping. Great. So we have now done a bunch of actions here. Um, Now, if I go to GraphQL just to verify that all of this is working, relationship, I have products, I have ID, I can query for name, I can also query for product images, and ID and image path. So obviously the data will be empty, but so the relationship and all is working. Now I can go back to my um, local development environment. I see that the foreign key constraint is also getting generated. So the workflow is working continuously pretty well. So the thing to note here is that you should always ensure that you're making schema changes when you're using the Hasura console through the CLI. But let's say you actually end up opening console served by the GraphQL engine. And then, in fact, if you make some change, a SQL change directly over here, remember that this will not be part of your migrations. And if you move across different environments, you will face issues in applying the schema and whatnot. And there'll be like a discrepancy between what is there on your local and what will be there on your staging. So it's recommended to once you start off with migrations, you actually continue to use the migration system that Hasura gives you. Also, do note that if in case you're using the Hasura console served by the server and you're using a different migration system not given by Hasura, probably like a Rails system, Alembic, or any other SQL migration system that you typically already use, you can continue to do that. There is no mandate to actually use the Hasura migration system. So you can technically use your own migration system and then track your schema changes separately. But the thing that Hasura requires is the metadata to be tracked. So in case you're not using the CLI console to track metadata, what you can do is you can actually like once you start using the console by the server, start making some metadata changes, uh, and then you can actually do a Hasura metadata export, which will actually do a metadata export. What this will do is in case you have some metadata in the server which is not part of your local environment, it will actually apply or create those necessary updates on your metadata folder, which has a different file structure, right? So you have the flexibility to use a different migration system as well. Um, and yeah, so just coming back to questions, can version control be done automatically? Doing it manually is error prone. Yeah, so version control, so by version control, what I meant is just the Git version control. You can use Git to take care of this as you keep creating new features for your application. So most of these schema changes will be tied to your application. Let's say you're building a new feature for your app, and you have a couple of tables to be created, or probably a column to be created. Then you create a branch for that on your version control, and then you work on the schema changes as well as your application code, which will all go in one deployment, right? So that's what I meant by version control, and I hope that is automatic, if I'm not wrong. Um, so by manual, what you can also do is, in case you have messed up the migration a little bit. So what I mean by that is, in case you've forgotten to use the CLI, but you've actually used the console server by the server, let's say you created off a table. What you can do is you can also manually create the migration file. So I can do migrate help. See, you can actually do, let me just do create help. So you can create a new migration file from scratch. This will be SQL from server. This could be SQL from files. This could be some metadata, or this could be from an existing GraphQL server, right? So existing Hasura server. So this will let you actually like, if in case you've messed up something, you can create a new SQL file locally with the SQL contents, and then apply them directly, right? So that's mostly about working with migrations. Great. So the next thing that I wanted to cover was environment variables and like local testing with actions and remote schemas and events, right? So let's say, so you obviously have some use cases for custom queries or custom mutations in your code. So I'm just going to make use of like a derived action. Um, let's say I want to validate the product before inserting into the DB. So insert product. The query will be insert products one, which will have an object. Yeah, I'm going to define a variable for this, and the type of it can be obtained on the docs. So I'm going to go to products one, and I'm just going to copy this type. And for the object, I'm just going to assign it the variable that we've declared. And I'll probably just want the ID of the product that was inserted. Now, typically you can try this out by sending an object in the query variables, but what we want to do is we want to override this mutation by writing a custom code. I'm going to click on derive action to do that. So what derive action does is it like templates the mutation that you've tried out in GraphQL, and then it creates some code gen for you to try out this mutation in the language of your choice. So I'm just going to make the naming simpler. Um, let's call it product input, and call this product output. Again, here this will be input. We most likely don't want a bunch of these conflicts. So these are all the auto-generated types from the GraphQL engine server, which uses a bunch of these like the var classes, the comparison operators, and so on. So I probably don't need all of these. I just need the input and output types. Um, and I'll also use the product output, which will return an ID. Awesome. So all of these are non-nullable, nullable, basically not mandatory to enter. So I'm just going to look at the handler here. So I'm using a Mac machine. So in Mac, if you have to communicate from GraphQL Engine's Docker container running locally to an endpoint on the same machine, which is outside that container, you can access it through host.docker.internal, followed by the port of the server that is running. Um, in Linux, I assume it will be the Docker container IP. And if you're running in host mode in Linux, you can actually use localhost followed by the port. I assume that works. So I'm going to just leave this as it is for now, and then click on create. Got it. Yeah, I don't need the product images. I'm just going to remove this as well. I think everything else looks fine. Just going to look at some comments in the meantime. Is there a way to have Hasura metadata export not override the last exported metadata? That way, if you forget to git commit between exports and mess up metadata, you can still have the old metadata. So the idea behind metadata is that there is only one source of metadata. At any point of time, your server will have the latest metadata. So if you do an export, it should ideally be the export that you should have on your local machine as well. Primarily because if somebody else is also making changes, you'd obviously want those changes to be applied as well. So not replacing the metadata that's already existing will probably cause inconsistency problems in your in your local development workflow. So it's always recommended that. So the single source of truth is the server. The server has the latest metadata about your application. So if something is messed up on your local machine, you can always like do a metadata export and then get the latest metadata at any point of time. So I assume that should be the workflow that you should follow. Just a follow-up comment from Spencer. I should make a script command that exports the metadata and git commits at the same time just to be safe. You don't need to actually do that. Um, you don't need to write a custom script, I suppose. The metadata export. So also whenever when you're using the CLI to make all of these changes, the metadata export will happen automatically. But in case you're using the server console, which is what I've done right now, I'll show you how to do the metadata export in that case. All right, so if you remember, I've just used the localhost 8080 console to create the action. But since action is not a schema change as such, action is just metadata. So I can actually do Hasura metadata export. And what this will do is it'll read the latest metadata from the server and will create the metadata for the action files that I've just created. I didn't use the CLI to do that. So if I go to actions.graphql, the insert product and product input and the output was created here. So I didn't miss anything because I used the server console. But ideally, I shouldn't be using this version of the console, right? So I should be just using the CLI served console. Either way. So now I have the codegen here. So I'm just going to browse code so we can use whatever console that's easier. So this is the codegen that Hasura generates for the derived action. What I want to do is I want to create a local version of this. So I'm just going to use Node.js Express for my custom action. I'll just copy the starter kit initially. I'll go back on this folder to do a wget of that. And I'll also probably unzip this files. So I have this, I can remove the zip file as well. Yeah, I have the Node.js server here, the source code for this. In fact, let me open this in VS Code. Great. Meanwhile, I think I can do npm install to have the setup ready on my local thing. So it's the boilerplate setup for Node.js is simple. We have like the Express app running and one sample route for people to try out. But what we want to do is we want to actually mm, 1 second. Yeah, we want to basically just copy the code gen that was generated for the action that I wanted to write. I'm just going to copy this piece of code, insert product. I suppose I can actually copy the entire thing and then can open the VS Code. Right, so a little bit of lag here. Right, I've now pasted this auto-generated action code. Right. So what we're doing here is that using the boilerplate, it's already given, and then what I'm doing is, in fact, I have to have fetch. Yeah. We have a Hasura operation, which is the mutation that we tried out in GraphIQL. Then we have an execute function which generates the GraphQL mutation, and we have a route called insert product. So now I have to go back to my action and actually update this route. It'll be called as insert product. I'll click on save. Right, so hopefully my npm install is ready. So I'm just going to do npm start. This will run my node server. Now what I can do is I can test this out by going to GraphIQL. So instead of doing the mutation directly, I'm just going to call the insert product mutation, which will be of very similar syntax since we use the types. I just need to give the image path, let's say some test paths, .jpg, and I also need to give the name of product. And the other columns have default values. The ID has a default value, the created at has a default value, and the updated has a default value. So we can leave them as it is. Now I've got a response back as ID1, but this is actually done by the action code. So the action is running on my local machine, which is executing the mutation. So going back to the code, so this is the request body that's being processed, and we're just calling the execute function, which actually defined the GraphQL mutation and making a fetch API call to the GraphQL endpoint. right? So if there's an error, return an error, or if not, return the product value, right? So we are pretty cool with this. We can write business logic to do the validation here, but that's not the focus here. I'm going to skip this. So the idea is that now you have a Node.js server running locally. So this could be any server. This could be your any language, Python, Java, any language, any framework. Some endpoint which is being exposed is what matters. So you can run this server locally, and you have this connected to your local instance of GraphQL engine for this particular action. Okay, so now we've actually just used a hard-coded local endpoint. The problem with this is that if you commit this metadata and then push this, the other person who's working on the same project will get the same handler. So obviously you have to change this to an environment variable, which we can call as action base URL. So so we'll probably have like one server, like one Node.js server with multiple post endpoints. So your base URL can be the Node.js server endpoint, followed by the path of the endpoint, which could be the route, which could be insert product, or depending on what mutation or query you're trying to write, this could be the other path, right? So we have to define this action base URL first before saving this. So I'm going to go to another tab. Here, I have to open the Docker Compose setup. I will have to write a new environment variable. So this will be action base endpoint. Let me call the endpoint as host.docker.internal here for my local environment. Because it's an environment variable, different projects, different people can just change this value on different environments. This value will be different. I'll do a Docker Compose up. Right, so let me verify the instance is running. Okay, so this is working. So I'm going to click on save. This will read the value from the environment variable ideally. Action base URL. What was the thing that I gave? Okay, I gave it as action base endpoint. I can change this over here to do action base endpoint. Now this will, so Hasura server will read this environment variable and apply this over here along with the insert product route. Okay, so this should still continue to work. I got the second product running on my node server. The mutation worked. Right, so if I look at the tree, it's a pretty huge one because of the Node.js server. Let's type into the Hasura folder. Now, also specifically on the metadata. So if I go to metadata and actions.yaml, we can see that the handler is the local host Docker internal handler. And I have to export this metadata so that the server gets the environment variable configuration. So I'm going to do a Hasura metadata export. Meanwhile, let me look at the questions if there are any. Cool, I think everything's fine. Right, so the metadata has been exported. Now if I go back to metadata and output the actions, we can see that now the base endpoint has been templated. So now you can do a git commit, and then the other person who's pulling these changes will be able to like work on the right set of values, right? Instead of the hard-coded local host the localhost URL for your server. Great. So this covers the environment variable for actions. You have a local server running as well. Everything's working. I think a similar thing applies for event triggers and remote schemas. You will add a remote schema, and this data will go into the metadata. So migrations are not created for this because this is not a schema change. This is more of a Hasura metadata change. So the metadata files will be modified based on this. And similarly for events, where you create an event on a particular table on an insert operation or something, you can give a webhook URL from env, which can be dynamically configured through the environment variable that you pass in. So if it's your Docker Compose, it's pretty easy. If it's on Hasura Cloud, that's also going to be pretty easy to set up. So the next step we're going to look at is to actually try out the staging environment. Now that I have a version of this schema and metadata ready, and also probably an action also ready. Cool. So what I'm going to do is I'm going to open Cloud. I'm going to sign in and then create a new project for my staging environment. Once I have a project, what I'll have to do is I have to apply the same migrations and metadata that I've created before. I'll try with Heroku. I've got the Heroku project ready. So let's give it a few seconds to initialize the project. So we have the Heroku app connected. We're using the Heroku Postgres. You can technically pass in any Postgres URL, any Postgres connection string for that matter. So I'm going to click on Launch Console. This will open up my Cloud Console. Now, now what we want to do is whatever we have created on our local machine, we want to transfer that data over here. Not in fact the data, in fact just the schema and the metadata. So what I'm going to do is I'm going to actually first add a env variable to secure my environment. On my local host, I didn't have a secure. Okay, I'm just going to add a admin secret. So this is probably like the first step that you have to do on Hasura Cloud. Once you have a project deployed, quickly add off an admin secret so that other people won't be able to access your project and make changes. Looking at the questions, there's a question which says events cannot have a base URL like actions. Why is that? Good question. So I think we have done a recent PR which fixes this. So if I think it's not deployed yet, but you can actually do a base URL like how you do it for actions. I assume that was a PR which was merged recently. I'm not sure if it's deployed as a release yet. Just checking on the pull requests because I remember seeing. In fact, I can look at the commits. It'll be probably easier to look at the latest commits. Schedule triggers. Yeah, so this is the PR that you're looking for. It says add URL templating for event triggers and remote schemas. So this will follow, I think this was merged like 13 days ago. I'm not sure if this is part of the release yet, but you have this feature ready. I understand why that will be useful. So you can have like one server for your events as well with the base URL of that particular server, followed by the path of each event that you want to maintain. Similarly, for remote schemas, that will be the case. We have multiple remote schemas and whatever. You have an env variable right now, but you can also add a base endpoint. Great. So yeah. So I'm just gonna add. Spencer is excited about it. Yeah, I'm too. Um, cool. So I think that's for the comments. Great. So I have to log in with my admin secret on my Hasura Cloud project because I've added an admin secret. Cool. So I'm going to copy this GraphQL endpoint. This is my Hasura Cloud project. Obviously, I don't have any schema or metadata here. Now, what we want to do is transfer my local setup to the cloud project. So I'll go to Hasura. And by default, there is a config.yaml which has the local endpoint, localhost 8080. And what I'm going to do is I'm going to do migrate apply. Um, and what I will actually do is I'll do, let me just create the command migrate apply endpoints. This will be this one. Secret. Since I have an admin secret added, I'm just going to show you the command, the basic command. So this is the command. I'll also probably pass in the admin secret in addition, because if I do a migrate apply without the admin secret, I think the CLI will ask for the admin secret. I'll do this in a separate tab meanwhile. So I'm just going to pass in admin secret. Yeah, I'm just waiting for the Hasura migrate command to apply for my cloud console. So right now the cloud project is in the US region, and there's a little bit of latency from India. But once we have multiple regions, especially India and the Europe regions added, the latency will be pretty low, and you can just apply migrations, open console pretty quickly. So I'll do so once I have the migrations ready, I'll also apply the metadata as an additional step. So I'm just waiting for both those to get ready. Yeah, so my migrations have been applied. I can actually get back to the screen. Right. So I can go to my data tab and see that there are some tables which are created, like the products, users, and product images. Obviously, action is not available yet, but the schema is created, as we know. Got it. So the next step that I have to do is do a metadata apply. So I'm going to do the same process again. Going to do metadata apply. So whatever metadata that I have locally, that will get applied. But we have one thing to solve before that. We have to have all of the environment variables that are required for the app. So without the environment variable configured on the cloud, we won't be able to access it. So I'm just going to go to the project settings, add another environment variable. I suppose it was the action base endpoint. And right now I can just give probably even the HTTP bin endpoint. We don't need the working version yet. We have to deploy the Node.js server somewhere so that we get the final URL. Right, so I have this set up ready. The metadata is going to be applied now. Great, so now the metadata has been applied. So I'll come back to the Cloud Console. I'll refresh this. So what we should see is the on-track tables or views should go to the track tables, ideally. Meanwhile, I can also show you some APIs that you can use to apply this migrations. So, sorry, the environment variables. This is on the Hasura cloud. We have an API which lets you like do a bunch of things like create a tenant and get some environment variables. So you can use this mutation to update the environment variables in a CI/CD setup. So instead of actually going to the console, into the dashboard and then manually adding your custom environment variables, you can actually automate this through the API that Hasura Cloud provides you. So the endpoint would be data or product Hasura, and then you can get a token from your project from the settings. So you can get an access token over here. You can create a new access token and then use that as the authorization header. That will let you actually do this automation. Cool. So for some reason we have, yeah. So if you look at the Explorer, we now have the queries available here. Yeah, I think I did another refresh. Great. So now I have the tables ready here. Now if I go to actions, I also have the action available here, and the handler is templated using the environment variable action base endpoint, and everything's working. Obviously, the base endpoint is a dummy URL that we've configured right now. But in a typical CI/CD environment, you will be deploying it together as a service, and you will pass in the right values. Probably also using the API to update the environment variable. So you can do this to apply environment variables dynamically. So this is all possible. So we've basically just done two steps to migrate an environment from your local machine to production. That is basically just Hasura migrate apply and then Hasura metadata apply. Migrate apply assumes that you have the latest schema in your version control system. So even if multiple people work on it, you should be able to get the changes merged into a single system. Cool. So what I'm going to do is I'm going to show another feature, which will be to squash the migrations. So in your local setup, you'll obviously have a lot of testing ground. You would have created a lot of files changing up data and so on. So if you go to migrations here, we have 4 folders. We can actually do a Hasura migrate squash. So do a help, it will show you what are the different options to do. You can actually specify from which migration ID from which version of migration you want to squash the data from. So that will let you squash multiple files into a single migration system. Um, so I'm just going to actually squash from the beginning, let's say. I'm just going to attempt this. Hasura migrate squash. Um, and obviously I need the admin secret to be set up. So I'm just taking it to a different screen. Yes, I want to delete the files with the folder. Right, so I have applied the migrations on a different tab with my admin secret. What I can show you now is, as a result of that, I should have a single squashed migration file. So I can go to migrations, and if I do an upload SQL, it will have all of the migration, the SQL statements in a single file. So if you have a pretty cluttered local setup where you were trying out something, you wanted to create some columns, then changed your mind later, you decided to delete off columns. It always happens in your local setup, right? So that will mess up your migration system in the sense of you will have too many files being created. This will be pretty useful if you have like 50 to 100 files created for your playground setup on your local machine. You don't want to obviously carry over all of your migration setup to the version control so that others will also not get it. So you can squash this. So once you squash it, it all becomes compressed enough to have more readability going forward, and also do this only if you're sure that this is one particular feature that you want to package and deploy. But if you want granular detail of, I want this column edit to be tracked separately, then you can skip that version to be squashed and then move a version ahead of that and then squash the other files together, right? So you can do a from and to and then squash a bunch of files. Cool. So that's broadly about transferring environment variables, applying migrations and stuff. Just as a final thought, we're probably running out of time. As a final thing, I'll just show you the production checklist. When you're so what we've done is add a admin secret as a first step, so that's pretty fine. Permissions, obviously, right now I've not added any permissions, but technically if you're exposing the app to any public facing endpoint, you should check the schema permission summary to see if any table is being allowed for any particular role to be selected as anything other than admin. And then obviously verify the permissions for all of the operations. Um, and disable APIs. So if I show you the local host setup, um, not on Hasura, on Docker Compose. If you look at the local setup, we have console enabled, and then there's a dev mode which is enabled for better debugging. You would not want to expose detailed log structure on your production client, so you can technically disable them, and you can also have more granular log types being enabled, and obviously the admin secret will be enabled for your uh, staging or production cluster, right? So the other stuff, uh, disable console. If you are using Hasura Cloud for deploying Hasura, then you don't need to disable console because you will also have um, this Pro tab, which you can access through the Hasura Cloud account, which will let you which will let you access some metrics about your project. and any production project should have all of these metrics up and running. You can track the errors, the usage, and the operations that are there and subscriptions that are running. You can also set up some regression testing. So this is a primary part of moving from local to staging, where when you make a particular change to your schema, you want to ensure that there is nothing that breaks because of that change. So you can define uh, operations. You can run some tests. So this will start appearing once you start making queries on the cloud, and then all of these queries will start appearing, and then you can pick and choose which queries which were previously executed on your cloud project. You can just choose to run them as part of a test suite, and if there is some query or mutation which is failing, you'll be able to now track and trace and then fix them before it moves to a production environment, right? So this is pretty useful to actually move from local to staging. Dev mode, as I mentioned before, this is particularly useful only in a local machine where when you're actually using actions, let's say, um, and you're getting an error back from the action. You want a detailed error structure, or even in Postgres, if you want the detailed internal Postgres errors to appear in the error structure, you can enable that, but you don't obviously don't need them in production, so you can disable them. um, and set up a love list. So you have a love list on the open source version as well, but on the cloud, you can actually set up a love list by choosing the operations on the UI, and then just click on what operations that you want to select, and basically restrict access to what queries can be done, right? Just looking at questions, where can I see examples of tests? I think we have some demo videos about regression testing. Probably I can link it at the end of this video. Um, so yeah, so this will typically be part of your CI/CD system, where you will run these test suits. In fact, if I go back to this blog post that we wrote last week, I think there is one GitHub repo which Gavin from our team had written before, who has done this migration setup as well as the regression test. So I think there's a regression test suite ID that you can configure here. There's an example usage on a GitHub action. So I think he's just using the v1.3.1 version and then applying some migrations and running some test suits, which is enabled, right? So you can probably look at this particular repo. I can share it on the chat. Cool. So this is fine. Um, so a love list is pretty similar. You can set up on your OSS version or on Hasura Cloud, depending on what queries you want to do. Um, I think yeah, HTTPS is a no-brainer. You have to enable them wherever you host it. Hasura Cloud gives you out of the box a Hasura app domain which has HTTPS enabled, so that's totally fine for you. Basically, Hasura Cloud takes care of all of the infrastructure parts of the app of the Hasura project, so you don't need to worry about applying these kind of certificates or HTTPS and how do I deploy or scale, or how do I even update Hasura versions going forward, right? So and log types, as I mentioned before, your local development can have a detailed log type, and your production can obviously have a different log type. And finally, for coarse domains, this will be important if, in most cases, I think you would want to restrict the queries to be made only from your application domain, unless you're exposing it to a public facing API where anybody can query from anywhere. Unless that's the case, you should actually restrict your particular website's app URL or or the server URL, and then just basically add them as a cost domain here in your server flag, or as an environment variable. So if it's as a cloud project, then you can just add this environment variable and add your application domains from where you'll be making HTTP calls from the client, right? So this is also generally recommended, right? So all of these typically you don't need them on your local setup, so you can configure uh, just these environment variables for your staging and production environments. As I mentioned before, this could be done through the API setup. I hope that was there on the Hasura Cloud docs. Yeah, so you can go back to the API reference and then do this automation. Gavin has also written the CI/CD setup, which showcases a bunch of these. Cool. I think, yeah, just looking at the comments, which was mentioned about our community call, definitely everybody should attend. I'm just going to open the link for the community call. The call here. We have a few exciting updates. We're going to have demos on the new support for MySQL. Now that now the demo that I showed you is also on Postgres, but Hasura is now supporting multiple databases, which includes MySQL and SQL Server is coming up soon. And you can also like add multiple data sources. So it need not just be one MySQL or one Postgres. So this could be multiple databases being connected to one instance of Hasura. So that will be pretty cool on the demo. And we have some zero downtime Hasura upgrades. That will also be pretty cool. Part of a follow up of moving from local to staging, and then how do you actually do maintenance updates on your local machine. Obviously, maintenance updates is just managing the versions of GraphQL engine. If let's say 1.3.3 was released, you will just do a release of 1.3.3 and then do a Docker Compose up. But on your cloud, this minor updates are taken care of automatically for you. If there's a breaking change, obviously we'll notify, and then you can do a manual update of that. So we also have a cool community demo by Yugabyte. Nikhil Chandrapa will do this, talking about distributed SQL database and Hasura on top of Yugabyte and how that scales pretty well. So yeah, pretty exciting tomorrow. So that's, I think, mostly from my side for today's live stream. Feel free to drop in comments on Discord if you have any further queries. Happy to help out on the process of moving from different environments. I suppose I still covered just a few fundamentals. There could be few more nuances that I might have missed out. But we can always do a follow-up stream covering the CI/CD setup, and also probably around how to actually move this into a production with regression testing, with cloud, and so on. So a lot of other things can be carried up on in a different stream. I hope this was useful. All right, so that's it for me from the stream. So see you folks on the next one. Until then, it's goodbye from Praveen. See you